Are we live? I think we're live. I think we're live. We're live. All right. Good deal. All right. Welcome to another live chat. Let me put on. There we go. Okay, that's better. That always starts off fun. So we have a lot to talk about. Of course, we're getting close to the winter forecast, and everyone's already putting out all sorts of interesting information out there. There's a lot going on with our pattern overall. A lot of blocking regimes showing up. A lot of interesting little signals that are starting to show up here. And it makes the winter forecast a little bit more complicated. So, for example, the snow in Siberia, not exactly very robust. In fact, pretty much below normal. That's expected to change in the model guidance. But, I mean, it's the GFS 15 days out. The European guidance is showing some snow, so maybe we push back up towards near normal. But that doesn't exactly support a major disruption of the polar vortex, right? But there's other things going on. And while I'm studying a lot of this data, it's making me take a step back in looking at the seasonal pattern and saying, okay, what is going on in our weather pattern? What's driving everything, right? Because it's certainly been very active. Everyone's been complaining about the fact that we haven't had a dry weekend in God knows when. And we get a lot of these storms that don't just hit and leave, but they kind of linger. You get these lingering troughs and whatnot. But we don't have a lot of polar air to work with, right? I mean, we got this modified Pacific polar kind of air, but not pure polar air. So what does that mean? Does it matter? Does it mean anything significant? Certainly should give you pause, especially when you start looking at all the models suggesting high latitude blocking for the season. I mean, the European seasonal guidance came out, and wow, everyone got excited. Then a whole lot of other models came out, and they're all suggesting blocking. Yeah. So the important thing is not to point out, hey, look, all these models are pointing out this one thing. The question is why. So let's talk about it. Let's take a look at some of the data. So this is the sea surface temperature anomalies throughout the entire world. And what do we see? Well, we see a lot of warm water, first of all. I mean, it's well above normal in many locations. We already know the Atlantic. And we already know that the Atlantic tropical season has been and continues to be above normal. Which, admittingly, my forecast was for, hey, look, strong El Nino should be shear. There was shear. But we also had a lot of storms. Is that a signal? Yes. I'm going to tell you why. So, what do we have standing out? Obviously our El Nino, obviously a warm water here, obviously warm water here, cold water here. This is a somewhat negative PDL. Not the strongest, but because this water is well above normal, the difference between the two suggests a negative PDO influence, okay? Pattern recognition. So we have that driver in the northern Pacific. We have this cool water here to the south of Hawaii towards the Baja of California. That is very important because when we take a look at the way that El Nino is set up, you would think like, hey, look, this is a strong east-based El Nino. But it's not acting like a strong east-based El Nino. In fact, when we take a look at the SOI values, they're suggesting more like a weak to moderate El Nino at play. So what's going on here? Okay, so let's see here. La Nina didn't act like La Nina last year. Not completely. This El Nino is not acting like it should, especially with an east-based component. You would think with the east-based strong El Nino, you'd get a lot of strong shear and substance in the Atlantic, leading to a very quiet Atlantic hurricane season. And you would support a very progressive subtropical jet stream, eliminating high latitude blocking, which isn't happening this fall. What about the Indian Ocean? Well, we got some very above normal water out here in the Indian Ocean, don't we? And we have some cold water around Southeast Asia. That would support a lot of lifting, a lot of rising air right around here, around Africa. And it would also displace the substance you normally would see here around the Atlantic more towards South America. And what is South America having right now? They're having a major drought. Okay, so now we're starting to piece this together in terms of the tropical forcing. So we know we have a lot of convection setting up around the date line. In fact, let's take a look at what's going on here. We have a lot of convection forming out here. Not so much here. There's your drought here. This activity across Africa, starting off in the Indian Ocean, crossing Africa, tells us we have a lot of lifting here. We have an active subtropical jet stream, which, I mean, all you got to do is look at the water vapor satellite picture right here. I mean, boy, does that stand out. So we have that. And oh yeah, we have a major typhoon that we're watching too. Okay, so we'll talk about that in a second. So the lifting is displaced. And honestly, when it came to the Atlantic hurricane season, I should have picked it up with the spring pattern. But it really didn't become evident until we got through most of this summer to see like, hey, look, this isn't changing. And what stands out is what's going on with our MJO and also our convection. It's been locked into phase 8 and 1 for all spring, all summer, now all fall. And where is that focusing? That's focusing a lot of convection around the date line. And what have we seen as a result of that? We've seen a very active subtropical jet stream interacting with an amplified polar jet stream. Okay, so that gives us the moisture. That gives us the short waves. And gives us the development of all this activity. But it doesn't explain the blocking now, does it? Because you could have all this and still not have the blocking. Okay? What is causing that? Well, sure as heck isn't the Siberian snow because it's running well below normal. Could it be transport? Well, what do you know? This is 5 days out on the GFS, the EP flux. Here it is from yesterday at 0Z yesterday. And you can see this transport occurring from the mid-latitudes to the mid-upper latitudes. And we're seeing this warping of the polar vortex, a stretching going on. And as we go 5 days out, and this is on the European guidance, you can see this stretching and warping taking place here. And it gets even more so as we get to 10 days out. Now, when it comes to the polar vortex, I really don't like to go beyond the 7 to 10 day period because then you really start to lose a lot of resolution in the guidance. I know a lot of people like to use the GFS and GFS ensemble guidance 10 to 15 days out. That's kind of nonsense to me, to be honest with you. I don't trust it. It's nice to look at, good to put on your screensaver, but I don't trust it too much. But when I'm under 10 days here on the European and I'm seeing this, first of all, I never take this verbatim, but what I'm seeing here is that this isn't just like, hey, look, it's a little warped and it's going to support more amplification of the polar jet stream. What it tells me is that there is something going on with mass transport in the atmosphere that is not typical of what we should see based on the observations that we have in Siberia, based on the observations that we have with our heat transport normally with a strong El Nino. So then we have to think outside the box here. What do we know that's unusual? Well, we've talked about it before, all of that water vapor. But the water vapor should cause a cooling effect in the stratosphere, and it does. But because of the cold environment overall, any type of transport of heat is going to lead to a further disruption and displacement of the nature of mass distribution in the stratosphere and troposphere. Now, there are some people who say, well, we don't have any research on that just yet. And that's true. That's a fair point. There's still a lot we don't know. And there are some guidance out there and some research out there would suggest that all of that water vapor, that's 150 to 130% above normal in the stratosphere, has very little impact on what's going on in the atmosphere. I don't know. Usually, personally, to me, when something is 150% to 130% above normal, to me, that kind of sticks out. I don't know. It has some sort of, from an operational aspect of it, it should have an impact. And this sometimes is a separation between those who do a lot of theory and research and those who work in operations. Because in operations, you're kind of dealing with real-time data and you're dealing with real-time evolution, and you have to think outside the box to say, what is happening in the atmosphere, so that way you can make a forecast and move forward and get a better understanding of what's happening in the atmosphere overall. Whereas research is a lot of, well, let's plug in data, let's see what the models produce and see if we could reproduce it 7,000 times and then we write a paper on it. Okay, so that's kind of like the separation. They're both very important worlds. I'm not saying that they're not important. They're very important to do that research and do that work and to try to understand what's happening from a mathematical aspect of it. But sometimes you have to take a look, you have to step away from the equation and take a look at what's happening here. There's obviously a vertical displacement in the atmosphere that's going on right now that is causing this type of disruption. And there's only one way to look at this. You have a very warm environment at the the troposphere. That's our El Nino. You have a very cold environment with the stratosphere. That's the influence of that water vapor. You have an imbalance. The atmosphere must balance itself out. Here's the balancing act. Now, how does this play out for the rest of the season? Not just yet. I'm going to be working on that this weekend. I know everyone wants to hear about the winter forecast. But for right now, let's just focus on the rest of fall. This signal would explain why in the GFS ensembles, the European ensembles, Canadian, pull any model you want. They constantly have a negative EPO, negative NAO couplet that continues on through really almost November. And the reason why is because we have this imbalance in the atmosphere. So you have your El Nino, you have your displaced forcing mechanisms with our El Nino, which we already discussed, which explains why we've had so much activity despite a strong El Nino event in the Atlantic. You had very warm waters, which already set the stage, and then you have your displacement over all your lifting. Instead of setting up over the Atlantic, crushing any type of tropical shortwave, now instead it's over Brazil, causing a massive drought and also a lot of warm, well above normal temperatures for their winter. And at the same time, you had a lot of lifting, which enhances your tropical waves and sets up the above normal environment. While that's all happening, you have an active subtropical jet stream over North America, sending storm after storm after storm. And that is where we are right now with this pattern. Now, for this weekend, the data originally was suggesting that this could be like another 1 to 4 inch or 2 to 5 inch type rainfall event. But we've seen that back off over the past 12 hours or so. And the reason why is now the short wave is over the Rockies. So now we have a better idea of the short wave that's coming in and running up against our upper level low. Now the upper level low is pretty well forecast. It really hasn't changed all that much. It's going to slowly migrate its way towards the Canadian Maritimes, block up the pattern, slow everything down, and act like as if we're on the LIE in terms of atmospheric movement. So nothing's really going to be moving all that quickly. This short wave, though, originally was forecast to be very strong. Now it's not the most impressive, but still strong enough to march its way towards the Great Lakes and set up another storm event for the Mid-Atlantic, especially Saturday evening through Sunday morning. So if you have plans on Saturday night or Sunday morning, well, you're going to need an umbrella. Sunday afternoon, look, there's going to be showers around, but it won't be a washout. Now, the subtropical jet stream here, it's going to play its game in terms of adding moisture to this whole event, but doesn't look like a full phase here. So when we take a look at our radar right now, let me zoom out here and take a look at all of America. A couple things I want to point out. Take a look at the Gulf Coast. That's a lot of moisture. Get used to seeing that over the next 6 months. Regardless of what winter forecast you follow, that right there is going to be a constant theme. So if you have friends and family down in the southeast, tell them they're going to have plenty of rainfall in a very wet winter. That is locked in for sure. There is our storm setting up here over the Rockies. This is heading basically right towards the central Great Lakes, and then it'll start to redevelop. Meanwhile, we have a lot of short waves rotating around our neck of the woods thanks to our upper level low. As this marches its way through, you're going to see some of this moisture get pulled into our storm, but this feature here is going to exit out well before we get any type of development. So let me just pull up our upper level pattern here. And what I want to show is that originally this short wave, in fact, here we go, this is even better. Originally this short wave was supposed to remain very strong and not collapse as quickly as what it shows now. This collapse in the short wave, by the time it gets into the Ohio River Valley, essentially is an elongated positively tilted trough, basically means we get a wave of low pressure developing off, let's say, the southern New Jersey coast, plenty of strong lifting, you got that moisture played in there, period of moderate to heavy rainfall Saturday night into Sunday, but it's able to exit out of there pretty quickly because it's not its own entity. It's now basically becoming entrained into the upper level low, moving into the Canadian Maritimes. But we keep our shower threat for Sunday, Monday, and Tuesday because of this extension of the trough. Basically destabilizing the atmosphere and keeping plenty of polar maritime air into our region, keeping the threat for scattered showers in place. But we're really looking at a half an inch to inch and a half of rain. Southern New Jersey could push over 2 inches in a few isolated spots, but that's pretty much about it. The only reason at this point now that we'd have to watch out for any type of flooding with this scenario is just because of all the rain we've had recently along the coast. The soil is super saturated. Pretty much anything you add in there, it's gonna puddle, lead to the potential for some localized flash flooding. So we'll keep an eye on that. And you can see that evolution taking place here pretty nicely here. And I know there's some talk out there of like, hey, what if this was in the winter? I'll touch on this. Maybe give you a little bit of a hint to that winter forecast idea. we're not really playing with a lot of polar air here. Not really. It's really Pacific air with a kind of a polar twist. So, in order to support a frozen precipitation event like this scenario, what you would need is for the upper level shortwave to cool the atmosphere itself to support frozen precipitation. If this was, let's say, that happened in December or January. So, without a pure polar air mass, what you need in this type of event is very strong lifting to cool the column of the atmosphere to support a frozen precipitation event. Just going to put that out there because I know I've seen a lot of people talk about that. So that is pretty much my spiel for this week. Now I'm going to take all of your questions. It looks like we're already very active. We're seeing plenty already on YouTube and a lot setting up here on our premium chat. And of course, if you become a premium member, some of you guys out there on YouTube and on X, if you become a premium member, all your questions are answered. And then I take the best questions out of YouTube and Twitter, if Twitter has any, or X, whatever they want to call themselves now. And that's how we roll. And of course, as we move towards the winter season, if you're interested in my backyard questions, like is the snow going to impact my backyard because I want to build a snowman and my kid's really upset because they don't have a snow fort, you can send those questions as a premium member, but I really don't answer them on any other type of social media. That's one of the differences, one of the perks with being a premium consulting member. So let's see what we got here. All right, and I will go take a look at me, and there we go. Okay, so card axes. That is some low pressure system at the western end of the Aleutians, right up through 500 millibars. Yeah, and that's going to be a theme, I think, for quite some time. Typically, we see this quite a bit in El Nino seasons. Whether it's Moduque, West Base, East Base, Central Base, it's kind of a theme. The question that we're going to have to watch out week to week is where exactly is that upper level low setting up? Because if it sets up in the Gulf of Alaska, well, that's going to push all your storms out in the Atlantic. If it sets up towards the far western side of the Aleutians, then you most likely are going to have storms cutting up towards the Great Lakes. So location, as always in meteorology, matters quite a bit. Lots of cold air over Siberia. Yes, but not a lot of moisture. Very interesting, right? The cold air mass is definitely building. I'm not seeing a lot push south into the mid-latitudes yet, though. Indian Ocean is rapidly warming. Yes, we talked about that, definitely. It's a factor. Lots of storms, but very weak, short-lasting ones that get ripped apart. That must be the tropical, yes. Steve, can we see your mouse indicator? I don't know what that means. There. We can't see your mouse. I wonder why. That is weird. I'll have to check up on that in the software. I know that they upgraded the software, so I might have to work on that and see what they changed here. Also, very strong easterly wind at 10 millibars in the tropics, either side of the equator. Yeah, the QBO is definitely going into a negative state. There is, oh good, Todd saw it. The QBO is definitely going into a negative state, and that is a factor in the high latitude blocking regime. A lot of people bring up the El Ninos of 97, 98 because strong El Nino. First of all, this El Nino is nothing like 97, 98, okay? Nowhere, anywhere near a shape, okay? So anyone trying to make that comparison, they're not paying attention to the observations. But more importantly, very important observation is that 97, 98 had a positive QBO, as in westerly winds in the stratosphere around the equator. This year, this time, we have easterly winds, the exact opposite. Why is that important? Negative QBOs, or easterly wind components, enhances transport of warmer air in the troposphere up to the stratosphere towards the higher latitudes. And it enhances the potential for high latitude blocking. So it goes into what we're seeing now in the pattern. So it starts to answer it. The problem with connecting it directly to the high latitude blocking we're seeing now is that the easterly component of the QBO just really started to get going. So it doesn't really answer what we've been seeing for the late summer through the fall. But it certainly would help to enhance that pattern now, wouldn't it? And it certainly isn't anything like 97, 98. Also, strong feed from the tropics to the poles, 10 millibars, 70 millibar vortex is still very spread out. Yeah, I'm noticing the lower portion of the polar vortex in the interaction between the stratosphere and the troposphere. It's not very robust, which is something that we have to watch. Now, something I'm going to be keeping an eye on for the rest of this month is if we actually see that Siberian snowfall buildup. And how does that influence the polar and the polar and Arctic air masses over Siberia and Canada? Because, guys, it's very important that we build up that snowfall in Canada at the very least. I'm going to tell you why. If you don't have a lot of snowfall building up over northern Canada at the very least, then when your polar air masses come down towards the Great Lakes in North America, they're going to moderate a lot faster. And the worst thing for a snow lover is a lot of storms and modified polar air that basically produces 42 in rain. Yeah, that doesn't make anyone happy, especially snowplow operators. Rob Allen asks, I hope this doesn't come off poorly. But if you don't want to answer, I understand. Last year, a good chunk of your forecast was based off the water vapor. I get you. I know where you're going. Seems you're hinting the same this winter. Does it concern you the water vapor EP flux, while it happened, didn't really lead to the winter last year? That is a very fair question. Okay. So, as I discussed last year, I must have mentioned this like about 50, 60,000 times. I literally wrote it in the discussion. I was not sure how the water vapor component in the stratosphere would impact our forecast. It was a huge wild card. So I made some assumptions based on the fact we've never seen it before. So how would the disruption work out? So there were some aspects I got right and there's some aspects I got wrong in that evolution. And it was a great learning experience. Now, what I did in that environment was that we initially had no transport. And I thought like, well, okay, right now we have a dry stratosphere and then this moisture is being transported in. And initially it was focused pretty much around the mid latitudes and really hadn't worked up into the higher latitudes. So I thought, okay, there must be some sort of transport mechanism taking place here, and that could disrupt the polar vortex. And although it didn't do it to the extent that I thought it would, and as a result, the whole forecast got blown apart. This year's a little different. This year, well, it's a lot different. First of all, this year, we have the transport completed. It's there, it's up there, it's not moving around. And we have a lot of research on how that transport happened and how it's influencing the stratosphere and troposphere. And we have observational data now showing the cooling effect and some of the warming effect in the troposphere. And now we're seeing observations, not just theory and wondering what could happen, but observations of that transport happening and how it's influencing the whole pattern in the warm season and heading into the cool season. So now we're no longer at a point where we're wondering, gee, what is all this moisture going to do? Now we know what it's doing. Now we can take it a step further and say, okay, we know what it's doing. How will it continue to evolve with a different QBO state in now an El Nino environment rather than a La Nina environment? And that is a very important difference because now you're dealing with a different component in the atmosphere, a different movement in the atmosphere, and a far more active subtropical jet stream to consider with everything else moving in this evolution. So the idea last year was that, okay, this moisture transport is a huge wild card. Not sure how it's going to impact us, but I think there's going to be enhanced moisture transport to deal with this. This year, we know what is happening. We already have everything super saturated and in place. Nothing is moving. It's there. It's going to be there for the next 5 to 10 years. Now we have to deal with it. So it's a different environment in that respect. But excellent question. Last year, the vortex got disrupted and split. Just the location was lousy. Yes, that was part of it. Location was bad. The evolution of the split was something that was difficult to forecast for, and also the way that the cooling took place, where the polar vortex intensified towards the end of the winter, which cut the winter short, also was an issue. That beautiful radar, exactly what we want for winter, then moves up the coast, then bam, we are buried. Yeah. I mean, look, here's the thing with El Ninos. If you look back at even the moderate to strong ones, it wasn't like 15 storms. Usually it was like a lot of misses, a lot of close calls, and then you basically get like 3 storms. Now, I don't think I'm going to be, breaking any news here as far as El Nino, but let me prepare you for this. El Ninos typically feature a lot of our winter storms mid-January to mid-February, right in that couplet, okay? And a lot of those winters are based on, a lot of people have a lot of great memories above normal snowfall, but really, it comes down to like 2 or 3 storms. That's pretty much it, right? Sometimes you get these winters where you get 15 winter storms, right? Those are extremely rare for the northern Mid-Atlantic. But if you're going to see blockbuster winter storms, they typically happen with El Ninos. Not promising, but I'm just saying, if you're looking for a blockbuster storm event, you want to be in an El Nino season. And if you get your high latitude blocking lined up just right, well, some of you guys hoping for snowfall, well, winter forecast equals lots of storms with no polar air. I wouldn't say no polar air. I'm just saying that you're going to need your high latitude blocking. And I'm saying that if people are going to make comparisons to the current, I'm seeing on social media a lot of people making the comparison to this current pattern, saying, I can't wait till it's in January and February. And I'm warning you, if this same exact pattern sets up with the way that it's set up, you're missing the polar air component, the deep polar air. Now, there's a lot of components that go into this, and there's a lot of air mass ramifications we'd have to consider, but you don't want a carbon copy of this. You really don't. There will be cold air this year, bet on it. I just had 2 nights in the 30s here in eastern Pennsylvania, which is early. It's going to be cold at the right time. Okay. Here's the thing. I want to say this. How do I say this? If your high latitude blocking is off, it creates a blocking situation, a limiting situation. I'm not saying that there won't be cold air. I'm saying that there are going to be some storms this year where the evolution of the 500 millibar low is going to be far more important than the current air mass that's already in place. And that's going to be an issue through the rest of this fall and maybe this winter. But again, I'm going to have a lot of work on my hands to kind of break that down, flesh that out, so that when we issue it at the end of this month, around October 20th is when I'm planning on issuing it, which is only 9 days away. And then hopefully the 25th, I'll be coming in from a flight, but I'm going to plan to do live chat that night. We'll see how that works out, whether or not I have jet lag or I might just crash. We'll see. Let's see here. Let's see if we have some good questions here on YouTube. Endorsing. Okay, so the sea surface temperatures in the Atlantic. Let's pull that up. Where is that? No, I have it somewhere around here. Did I delete it? I shouldn't have. Oh, there it is. Of course, the first one. I kept clicking on all the other ones. Okay, so good question about El Nino. Should I say the NAO and the sea surface temperatures in the Atlantic. This signal right here would suggest higher potential for a negative NAO regime. The intensity of which is still in question. See, the forecasting of the NAO can be a little bit of a complicated factor because you can't just look at the sea surface temperatures. You have to look at the entire couplet. And you have to figure out whether or not the upper level dynamics link up with the boundary layer dynamics to feed back on themselves. Now we got the first part here with the sea surface temperatures. The only thing that concerns me is that we have a lot of warm water. Usually I want to see some colder water also showing up and a nice gradient setting up. I really don't have that here. The one thing that's interesting with all that warm water is that in terms of clashing with the continental air masses, it produces some very dynamic and impressive storms. Now we have some very warm water set up off the mid-Atlantic coast here. If the gradient interacts just right with polar and Arctic air masses, we get them to transport towards these regions, they're going to significantly enhance cyclogenesis and support coastal storms that are going to be capable of bombing out. And they're going to be slow moving because you get one storm blowing up, it'll feed back on itself and slow down the whole storm track in this area. But that only happens if you get the trough here to line up correctly, to build the ridge here around, let's say, the Rockies, so it sets up the right wavelength to set up storm development around North Carolina to the Delmarva Peninsula, to allow for storm development around the Canadian Maritimes, to allow for building heights here around Greenland, to all feed back on itself. Now, model guidance so far is suggesting that might be the case. But what I want to make very clear is you get any one of these features off by just a little bit, and it leads to disappointment. I'm saying this that way you understand how difficult it is to line up this pattern. There's going to be a lot of excitement out there. And you're going to see a lot of people posting a lot of long-range guidance. And you have to understand that while it looks really impressive, it's a smoothed out solution. And the devil is always in the details. Could a snowstorm happen in late October? Sure. Not this year, but sure. I say not this year because I see no indication of that type of polar air mass in this environment. But can a snowstorm happen in October? Sure it can. It's very rare. And honestly, actually, I did some research on this a couple of years ago. I found that when it snows in October, the rest of the winter is kind of blah. So I don't know whether or not you'd actually would want that. But in theory, can it snow in October? Absolutely. But I don't see any indication of anything like that happening. Let's see here. So we have had some great questions so far, and it's already 8:40. Wow, not bad, rocking it out. But right now, let's see. Actually, this is the NAO forecast, and I talked about this in the long range thoughts today for premium members. I figured I'd just bring it up now. If you're looking for any type of relaxation in this pattern, the I like using the European ensemble guidance in this type of indicator here. Again, not for detailed data, but just kind of get an idea, overview of the pattern overall. And when I see a combination of the EPO in a negative state and the NAO in a negative state, what that basically tells me is that we're in a stormy pattern for the rest of this month. Now that doesn't tell me what's going to happen in your backyard or or when it's going to happen, how it's going to happen. But what it tells me is that the pattern overall is favorable for more interaction between the subtropical and polar jet stream and more storm development along the northern Mid-Atlantic coast and really the entire East Coast overall. I do find it interesting that we haven't seen a lot of prolonged relaxation in the pattern. Normally, in this type of environment, you see a intensification and then a long relaxation. And that's because of the wavelength changes. But we're not seeing that this year. It's much shorter. It's almost flipped. We're seeing longer negative phases, shorter relaxation, and then we go right back into the amplification again. And I think that all plays into the overall environment that we are in. Now, notice the Arctic oscillation here. It's negative, but then it goes back into a positive state again. And this kind of plays into where I was talking about. And let's see here. Back to this point right here is that the mid latitudes are awfully blocky. The higher latitudes, though, really aren't playing that game so far just yet. And that's what I mean by our polar and Arctic air masses. They're kind of staying up to the north. And what we have right now, and I'm not saying this is going to remain the case, but what we have right now is a lot of modified polar Pacific mixture type of air masses coming in from here, the Gulf of Alaska, and driving into North America. So I just kind of want to make that clear that we really haven't dealt with true polar air masses yet. Now, if we get a sustained Arctic oscillation, negative Arctic oscillation, to couple with everything else that we're seeing, hey, there's going to be a lot of people on this forum and on this discussion who are going to be very, very happy. And I always get the question, will we see more snow than last year? Well, considering portions of the forecast area had 0 inches, I am very confident in saying yes. It's not going to take much. I just need one storm, right? At this rate. Let's see. Got more questions as we hit to 8:45, and we'll see whether or not. So far, let me just reset this. So yeah, I think I answered all the questions that everyone was looking for. Look at that. So, no kidding, one on X. Okay, what is it?
Somebody said I may have missed this. A lot of talk it ends up?
Neither. Um, Based on what I'm, first of all,
I'm not
I
sure if
think,
that sound picked me up, but
okay, so the question is between East Base and West Base El Ninos, what do I think we're going to be dealing with? And let me just, okay. There's been a lot of focus, and I know that there's some individuals out there, some people who are in college still, who vehemently say it's an East Base El Nino, it'll be this pattern, and that's it. The problem is that the SOI isn't acting like that, and our forcing mechanisms aren't acting like that. An East Base El Nino typically has a lot of your convection to the south of Hawaii and a lot of displacement of your troughs and your high latitude blocking to the east. You get an east base negative NAO, and you get a lot of your storm development out towards the Atlantic, not so much towards the east coast. Not only that, but your upper level low around the Aleutians more locked into the Gulf of Alaska. None of that is happening this year. Although clearly we have some very warm waters and the warmest waters in the eastern Pacific. So if you just want to go based on sea surface temperatures, absolutely, there's no doubt about it, East Base El Nino. But if you want to look at forcing parameters, which is more important, it's acting more like a central based. Now, West Base Modica is, and we'll just go West Base, all right. It has a lot of the convection focused from the date line onto the west. And the warmest waters are typically in Nino 4 and 3.4. No indication that that's happening. In fact, Nino 4 is going to be the coolest of the four. It looks like, based on the subsurface temperatures, that we're going to be focusing more towards the warmest waters as we move towards winter, shifting towards Nino 3 and 3.4, which is basically to the south of Hawaii and towards the date line, right in that area there. Um, Typically, Nino 1 plus 2, because of the shallow nature of it, it can crash pretty quickly. And there's some indication that that might just happen. So, what you end up with is not the shifting of the 2 degrees Celsius plus type water towards Nino 3, but just a complete collapse in Nino 1 plus 2, which is very possible because of the shallow nature of the water there and just the stabilization in Nino 3 and 3.4. But let's just say none of that happens. Let's say that the current sea surface temperature regime, and let me see if I can pull that up here. Okay, let's say that this remains locked in. Okay, has anything else changed? You have an east base now. The lifting parameters aren't changing. All your focus of your convection's here. Your upper level low is here. So the focus of the orientation of sea surface temperatures this year, I can't say that going forward, but this year is not what you should be focusing on. Because if you had a strong, if the atmosphere is reacting to just that component, then your SOI would be plummeting and you would be around the minus teens and 20s. But we're nowhere near that. Still, the SOI is acting like an El Nino influence, but it's more like weak to moderate. And your convection wouldn't be developing around the date line, it'd be developing here. As you can see, that's not happening. So, it's not the most important thing to me to study in terms of basing a whole seasonal forecast on it. It's certainly something that you should study, but I wouldn't base a whole seasonal forecast on it based on what I'm seeing. Do you think, okay, good question from Hockey. Do you think winter temperatures will be above normal or below normal, and estimate how many degrees? Thank you. I don't know yet. I'm working on that this weekend. That's the honest truth. I want to get more data. I want to get a better understanding of what's going on in Siberia. I want to get a better understanding of what's happening with the polar and Arctic air masses. You're essentially asking what my winter forecast is going to be. And I still have to work on it. And I hope to have that done this weekend and have it issued on the 20th. Premium members, I should have it up before the 20th because you're premium members and so on and so forth. But I want to work on it this weekend and really nail down those factors before making any other additional statements. Because I still have some questions on that. And here's the thing. When I'm looking at this whole pattern and looking at how to describe this winter, one of my goals, which I always have, is not just to make a map and say, okay, here's the map and leave it at that. I want to be able to describe what to expect in this winter pattern and how to prepare for it. And also explain what could change my forecast. So that way you're best prepared. Because issuing a map, especially a flashy one with heavy snow or above normal snow, doesn't really tell you what you need to know to properly prepare for the winter ahead. Or any other season, really. Because if all you're looking for is above or below, you could pull up any model for that. But to illustrate what that means in terms of impacts to you, well, that's a totally different story. Because you can have above normal temperatures and above normal snowfall. The question is, how do they all interact? And more importantly, if you have above normal temperatures with above normal snowfall, you also have to worry about above normal flash flooding concerns. All these little things that we're going to be working out and try to figure out as we move forward. So I'm not trying to dodge the question, Hockey. I'm really, really not. But I want to fully flesh out my ideas before answering that. And I will have that answer in the winter forecast. I can promise you that. But I really want to work that out and finish it up before moving in that direction. And any other questions on X? Nope. Alrighty then. Very good. And we got all the questions for the premium members and all the questions on YouTube. And it is 8:53, so I'm going to call it a night before I start losing my voice. I want to thank everyone for coming out, as always, and asking wonderful, outstanding, super questions. I really appreciate it. And definitely get ready for this weekend. I think the worst part of this weekend is going to be Saturday night into early Sunday morning, which, let's be honest, unless you're really into going out to clubs, which I never was, because quite frankly, it's too loud, it's too smoky, and the music isn't always that good anyway. So unless you're really into that, you're pretty much going to miss the worst part of the weekend, which is the heavy rain. So if you want to stay in Saturday night, play some Monopoly, it's okay. Saturday morning should be fine. Sunday afternoon, a few showers, but not a complete washout. Sunday morning looks like a bit of a wet period of weather, and of course Saturday night as well. So plan around the weekend in that respect. But if you have outdoor activities, hey, look, after Saturday afternoon, have an umbrella handy. That's my best suggestion. In the meantime, have a wonderful evening, and as always, stay safe out there.